Have you ever wondered why algebra is considered an essential subject in our education system? It's more than just a branch of mathematics dealing with symbols and their manipulation. Algebra serves as the bedrock for complex problem solving, pattern recognition, and logical reasoning. It's a crucial thread woven into the fabric of various fields, from engineering to economics and computer science, and even permeates our everyday lives. So let's delve into the fascinating journey of algebra through the ages. Our journey begins in ancient times, where the roots of algebra can be traced back. The beginnings of algebra, believe it or not, were not in the modern form we know today, but rather as a series of practical problems that needed solving. The Babylonians and Egyptians were among the first to use algebraic methods, simplifying complex architectural and trade problems into more manageable equations. The Babylonians, in particular, were masters of arithmetic and used a base 60 number system, quite different from our base 10 system today. They had a knack for solving quadratic equations and even knew how to calculate interest, which is a concept that still very much has a place in our modern world. The Egyptians, on the other hand, used algebraic methods to solve practical problems related to their infrastructure, such as calculating the slope of a pyramid or the area of a field. Their methods were less abstract than the Babylonians, but were still very effective. Now let's take a leap forward to the classical Greeks. The Greeks, led by mathematicians like Euclid, introduced geometric algebra, where numbers were represented as lengths or areas. They developed the idea of deductive reasoning, a cornerstone of modern mathematics. From there, we move to the Islamic Golden Age, a period marked by significant advancements in various fields, including mathematics. It was during this time that algebra was formalized and given its name by the Persian mathematician Al-Khwarizmi. His book, Hisab al-Jabr wal-Muqabala, introduced the systematic solution of linear and quadratic equations, laying the groundwork for modern algebra. Al-Khwarizmi's work was later translated into Latin, allowing it to spread across Europe and eventually the world. This marked a significant turning point, as it laid the groundwork for the development of algebra into a separate branch of mathematics, distinct from geometry and arithmetic. Algebra has come a long way since its inception, evolving and growing with each passing era. It's a testament to the power of human curiosity and intellect, a story of how we've sought to understand and make sense of the complex world around us. From ancient civilizations to today's digital age, algebra remains a fundamental tool in our quest to decode the universe. From its humble beginnings, algebra has evolved into a sophisticated branch of mathematics. The journey of this mathematical discipline is a fascinating tale, filled with intriguing discoveries and breakthroughs. In the ancient world, algebra was primarily used for practical purposes, such as commerce, land measurement, and architecture. The Babylonians, who lived more than 4,000 years ago, were among the first to use algebraic methods. They solved linear and quadratic equations using tables and geometric methods, but it was the ancient Greeks who first introduced symbolic algebra. In the 3rd century BC, the Greek mathematician Diophantus began to use symbols to represent unknown quantities. This was a significant shift from the practical applications of earlier cultures to a more abstract form of thought. Diophantus is often referred to as the father of algebra, but his work was primarily concerned with solving specific equations rather than developing a systematic approach. The true birth of algebra as we know it today came much later, in the 9th century, with the Persian mathematician Muhammad ibn Musa al-Khwarizmi. His book, The Compendious Book on Calculation by Completion and Balancing, introduced the fundamental algebraic methods and the systematic solution of linear and quadratic equations. This marked the beginning of algebra as a separate discipline within mathematics. Then, in the 16th century, another major advancement occurred. The Italian mathematician Girolamo Cardano published Ars Magna, or The Great Art, where he provided solutions to cubic and quartic equations. Cardano's work laid the groundwork for the development of complex numbers and the expansion of algebraic knowledge. Fast forward to the 19th century, and we see the development of abstract algebra. This was a significant shift away from the concrete and towards the abstract. It was no longer just about numbers and equations, but also about concepts and structures. Mathematicians like Augustin Louis Cauchy, Évariste Galois, and Émile Noether made significant contributions during this period. They explored concepts such as groups, rings, and fields, which are fundamental to modern algebra. These breakthroughs have continued into the 20th and 21st centuries, with algebra playing a crucial role in the development of other mathematical disciplines, such as topology, number theory, and algebraic geometry. It has also found applications in computer science, physics, and engineering, among other fields. The evolution of algebra is a testament to the power of human curiosity and creativity. It shows how a simple tool for trade and measurement can evolve into a complex and elegant discipline that helps us understand the world around us. The journey of algebra is far from over, with new discoveries and applications continually pushing the boundaries of what we know and understand. As we can see, algebra has been shaped by the collective efforts of brilliant minds over centuries. It is a testament to the power of human ingenuity and the unending quest for knowledge. Today, algebra forms the backbone of many scientific disciplines and plays a crucial role in our daily lives. In our modern world, algebra is not just a branch of mathematics, it has evolved into a universal language. It's the code that allows us to understand and translate the complexities of our universe into comprehensible terms. Scientists in fields as diverse as physics, engineering, and computer science rely on algebraic principles to make groundbreaking discoveries and advancements. Picture a physicist calculating the trajectory of a space probe, an engineer designing a sustainable energy system, or a computer scientist developing a new algorithm. These professionals are leveraging the power of algebra to push the boundaries of what's possible. But the influence of algebra extends beyond these scientific fields. It shapes the world of economics too. Economists use algebra to predict market trends, evaluate financial risks, and make strategic decisions that impact entire economies. It's the invisible hand guiding the flow of money and resources in our global economy. Algebra's reach, however, doesn't stop at high-level professions. It is deeply woven into the fabric of our everyday lives. Each time we balance our checkbooks, calculate the interest on a loan, or analyze data to make informed decisions, we are putting algebra to use. It's the unseen force that helps us navigate through the complexities of life. It's also worth noting that algebra is a critical stepping stone in education. It lays the groundwork for more advanced mathematical concepts, fostering problem-solving skills and logical reasoning abilities in students. By mastering algebra, students are not only empowered to tackle complex problems, but also encouraged to think critically and creatively about the world around them. So the next time you look at an algebraic equation, remember, it's not just a collection of symbols and numbers. It's a powerful tool, a language that speaks to the underlying patterns and structures of our world. It's a language that, when understood, allows us to perceive, interpret, and even shape the reality around us. Thus, algebra is not just a subject in our textbooks, but a tool that helps us understand and shape the world around us. So, what have we learned today about this fascinating branch of mathematics called algebra? We've embarked on an intriguing journey through time and space, tracing the origin and evolution of algebra. It all began in ancient civilizations, where the first inklings of algebra were born out of necessity for practical problem-solving in daily life. Over time, this rudimentary system of calculation evolved into a sophisticated mathematical discipline, marked by the use of symbols and equations to represent and solve problems. As we moved forward in our exploration, we saw how algebra has continually evolved, adapting to the needs of each era. This dynamic branch of mathematics has been shaped and reshaped by brilliant minds across the centuries, each contributing to the rich tapestry of algebra as we know it today. We then delved into the significance of algebra in our contemporary world. Algebra is not just a subject confined to the classroom, but a fundamental pillar of our society. It underpins numerous fields, from physics to engineering, economics to computer science. It's in the calculations that send rockets to space, the algorithms that drive our digital world, and the financial models that govern our economies. But more than its practical applications, we must remember the profound impact algebra has on our cognitive development. It cultivates problem-solving skills, fosters logical reasoning, and encourages analytical thinking. By engaging with algebra, we are not just learning to manipulate mathematical symbols and equations, but we're also developing a framework for understanding the world around us. Algebra's value extends beyond the classroom, permeating every aspect of our lives. It's in the budgeting we do to manage our finances, the interest rates we calculate for our loans, and the data we analyze to make informed decisions. And let's not forget, algebra serves as a foundation for more advanced mathematical concepts and applications. It's the building block that paves the way for further study in the vast field of mathematics. In essence, algebra is a powerful tool for understanding and interpreting the world. It's a language that helps us describe patterns, represent relationships, and solve problems. It's a discipline that cultivates critical thinking, nurtures curiosity, and encourages lifelong learning. Remember, mastering algebra is not just about solving equations, it's about gaining the skills to solve complex problems, understand patterns, and make sense of the world. So keep exploring, keep learning, and keep growing your understanding of algebra.